Hello, my name is Michael Weiss, and I will be presenting my river dynamics project. What I'm going to be talking about in this project is straight rivers, curved rivers, sediments, and more about the watersheds and rivers and water flow and things like that. Alright, so in our first activity we did the curvy, or as you would say, meandering line for a river. And what that is pretty much just a curved river, as it is in its title, filled with sediment and made up of sediment. Now, what would happen though with this river is when it got a lot of water from our hose, as you can see right here, very much, the river would be filling with water. But over time, there'd be a lot more water coming in, and it'd rise over and make water form new channels, as you would say. And these new channels would then break off and make itself into new ones, and maybe it'd come over here too. It can pretty much break off wherever it wants to, making a lake, flooding it as well. But with these sediments, which is, as you can see, all here, wherever you want, it is being pushed down, no matter the size, with the water. Now, the smaller sediment, though, takes a lot less shorter time to get all the way down to the bottom of the lake here, where you would say just like the lake would be for the bottom of the river, which is the mouth. And the smaller sediments take lesser time because of its light weight. So say here's a small sediment, and here's a larger sediment. Now, this smaller sediment moves really fast. This larger sediment, it takes its time to get down there because of its weight. And we'd have the larger sediment be called bed load because of its lightweight scoop just scratching at the bottom of the water of the river going down here. The smaller sediment would be a suspended load, which is it floating in the air. So like here, we'll say is the bottom of it, and here is the water. Sorry, I changed my color. And then here are the larger sediments right here, scraping at the bottom, moving, while the smaller sediment is up here floating in the water. Diagram that better. Yeah. And so we have channels. Oh, I almost forgot. What we call on the sides of the rivers, say here, this is what we call the banks, which is pretty much say if this was like the sandy part of the river side, like if there's a bunch of trees over there too, this would be the bank. Pretty much the sides of the rivers are called the banks. So we can say that's here, say this is here, pretty much all here. So the banks would be right here and right here. Alright, so in our second picture here, we have what is the straight river, which plain and simple is a river that is straight, pretty much just going down into a river. And in the river, like any other, there is bits of sand, just like in our picture on the left. So let me draw in the sediment. And as you can see in the picture here on the left, a lot of water is running down it easily and fast. And with it, small bits of sediment and larger bits of sediment are moving with the water flow. And I'll mark that right here, right above it. Small sediment and larger sediment. Now, what is different with the straight river is that the sand has only one place to move, which is down. But what the problem is with the sand is the different size of it. Now, the larger sediment takes a little bit longer time than a smaller sediment would because of its larger weight. And that would be the bed load of the sediment. Now, with the small sediment, it goes around really fast, as you can see with the arrow there. And because it is so fast, it is because it has a lighter weight. And with the water flow going down a river, it would be a part of the suspended load, which is the load that is of sediment floating in the air that with its light weight cannot stay on the ground and scratch up against it, which was what the larger sediment would do. And now, right here in picture on the left, we have a large pile of sediment. Now that right there is mostly the larger sediment, while down here is the smaller sediment. And with the smaller sediment flow, a lot of it mostly is larger sediment becoming surface runoff, while most of the smaller sediment goes into the lake down here. Alright. One thing I forgot to add on is that mostly the surface runoff with the larger sediment stayed right up here, while most of the smaller sediment was staying right down here. This is because the larger sediment, mark that right here, and the smaller sediment here, is because the larger sediment's weight doesn't really get pushed a lot more when it's up here with the river, whereas the smaller sediment would be going all the way it can down the river, down to the bottom of our little lab station.
Alright, so there is my river dynamics project. My name is Michael Weiss. Thank you very much, Mr. Fish, for teaching me more about water dynamics, river dynamics, and things like that. Alright, thank you very much, and goodbye.